So in this next example, solve the differential equation d squared x over dt squared plus 2dx over dt plus 5x is equals to sine 2t, given that t is equals to 0, x is equals to 3, and dx over dt is 0. So you'll be told to solve this differential equation with the method of undetermined coefficients. So how do we solve this differential equation with the method of undetermined coefficient? That is the D operator method, isn't it? So how do we use the D operator method? Meaning here the independent variable is x with respect to t, isn't it? So you let x to be equals to u plus v, where u is the complementary function and v is the particular integral. So where there is x in the equation, you put u. Where there is x, then you'll have d squared u over dt squared plus 2 du over dt plus 5u. Then it is plus. Where there is x, you now put v. Where there is x, you now put v. You'll have d squared v over dt squared plus 2 dv over dt plus 5v. Then the whole of that is equals to sine 2t. So we've substituted x is equals to u plus v. The first case is u, then it is plus, the second value of x is v. So the first part is the complementary function which we equate to 0. So the first part, which is d squared u over d squared t plus 2 du over dt plus 5u, you equate to 0. When you solve that, you get the complementary function. The second part, which has v, you now equate to the function itself, isn't it? So the second part, which is d squared v over dt squared plus 2 dv over dt plus 5v is equals to sine 2t. That is equation 2. Now, when we solve the second equation, we get v, the particular integral, isn't it? So let us start with the first equation. So the first equation is very simple. What you know is that in the first equation, you let d to be equals to ddt. That will implies d squared is equals to d squared over dt squared. Then after that, you substitute d with m, isn't it? Are we together? So it means here we will have d squared over dt squared will be d squared. And d squared, if you substitute with m, it will become m squared v, m squared u. Are we together? We are in this first part. D squared over dt squared is d squared u plus 2 du, because ddt is d, isn't it? Plus 5u is equals to 0. So where there is d, you substitute with m, you have m squared u plus 2mu plus 5u is equals to 0, isn't it? So u is a common factor. If you factorize u outside, you remain with m squared here, then here plus 2m, then here plus 5 is equals to 0. So when u is equals to 0, the differential equation does not exist, isn't it? So the second equation factor there, which is m squared plus 2m plus 5 is equals to 0, that is now the auxiliary equation. So the solution of that auxiliary equation is what will determine the form of a complementary function, isn't it? So what is m? Use quadratic formula. M is minus b plus or minus square root of b squared minus 4 ac over 2a. What do you get? Is equals to what? Minus b is minus 2, isn't it? Plus or minus b squared is 4 minus 4ac, 4 times 1 times 5. So you get negative 16 there, isn't it? So square root of negative 16 is 4j, isn't it? Square root of negative 16 is 4. Then everything is over 2a, meaning everything is over 2, isn't it? So what do you get to be m? Negative 2 divided by 2, then plus or minus 4 divided by 2, 2j. So this solution is in the form alpha plus beta j. So alpha is a real part that goes with the exponential function, isn't it? And beta is the imaginary part that goes with the trigonometric functions, isn't it? So it means our complementary function u will be a cos beta t, isn't it? Because our independent variable is t, isn't it? Beta t, but our beta is, so it is cos 2t plus b sine 2t. Then it is always exponential alpha t, but alpha is, so it is exponential negative t. The independent variable there is t, isn't it? Are we together? So are you seeing we found the complementary function u? This is the form. When you have a real and imaginary solution, this is the form, isn't it? When you have a real and imaginary solution, the imaginary goes to the trigonometric function, the real is always for the exponential, isn't it? Are we together? Good. So having found u, we now want to get v. We now want to get v. So record your u. So here we found u is equals to a cos 2t plus b sine 2t, then the whole of that is times exponential negative t. T is the independent variable, isn't it? So we found the solution of u, now we want the solution of v, Roman 2, isn't it? Roman 2. Now Roman 2 we have d squared v over dt squared plus 2dv over dt plus 5b is equals to, so what is the choice of v? When we are choosing v, you are looking at the function, not complementary function, the function, isn't it? Are we together? You are looking at the function which is here, isn't it? So what is v? Because we have sine 2t, meaning v is going to be k1 sine 2t and k2, k1 cos 2t and k2 sine 2t, isn't it? Here, whether you have sine 2t or cos 2t, it will be the same thing here, isn't it? Whether this was sine 2t or whether it was cos 2t, cos and sine goes together, isn't it? Are we together? So we have k1 cos 2t plus k2 sine 2t. Then you now check. Is either cos 2t or sine 2t in the complementary function? No, because this is cos 2t times exponential negative. That is a common factor outside the bracket, isn't it? Yes. So it means there you have a exponential minus t cos 2t plus b exponential minus t sine 2t. So you see, these are the terms which you have in the complementary function, and you see we don't have those terms here, isn't it? Are we together? So it means what we have here is not in the complementary function. It's not in the complementary function. So it means this is the choice of v. So we found v, the choice for v is that, isn't it? So we now need to differentiate v until we get dv over dt and d squared v over dt squared, isn't it? So if we differentiate v with respect to t, we get dv over dt to be equals to, differentiating cos 2t, you get negative 2 sine 2t times k1, that is negative 2k1 sine 2t. If you differentiate sine 2t, you get k2 positive 2, yes, good, cos 2t, isn't it? Then times your k2, you get plus 2k2 cos 2t. Then you differentiate this for the second time, isn't it? You get d squared v over dt squared is what? Minus 2k1 is a constant. If you differentiate sine 2t, you get 2 cos 2t, isn't it? So 2 cos 2t times negative 2k1, you get negative 4 k1 cos 2t, isn't it? When you differentiate remember positive 2k2 is a constant. If you differentiate cos 2t, you get negative 2 sine 2t. So negative 2 times positive 2k2, negative 4k2 sine 2t. Go back to your equation. Here we have d squared v over dt squared is this. You substitute it there, isn't it? You have negative 4 k1 cos 2t minus 4 k2 sine 2t. Then it is plus 2 dv over dt, meaning dv over dt you multiply by positive 2, and dv over dt is the whole of this, isn't it? You multiply it by positive 2. Positive 2 is just 2, isn't it? So 2 times negative 2. So it is minus 4k1 sine 2t, positive 2 times 2k2 plus 4k2 cos 2t. Then in the end plus 5b, meaning positive 5 times the whole of v, isn't it? I have positive 5 times k1 plus 5 k1 cos 2t plus 5 k2 sine 2t. Then the whole of that is equals to what? The whole of it is equals to sine 2t, isn't it? So when it is equals to sine 2t, it means it is always sine 2t, coefficient here is 1, then it is plus 0 cos 2t. That's why cos 2t is not there, meaning its coefficient is 0, isn't it? So it is the coefficients you are comparing. Are we together? Good. So can you start comparing the coefficient of the first one? Coefficients of sine, isn't it? Coefficients of? So we have sine here, there's sine here. How many sines do we have? There are 3. There's sine here, isn't it? What are those coefficients? Compare them. Negative 4. So the coefficient here is negative 4k2. The coefficient here is negative 4. Where are we starting? No, that is another. We are starting from here. And we are ending here. So it is negative 4k2. And another one? And positive, negative 4k1. And another one? Plus 5k2, isn't it? So if you simplify, negative 4k2 and positive 5k2, so you remain with k2. Then minus, I'm using this negative here, minus 4k1 is equals to 1, meaning the coefficient of sine t this side, which is minus 4k2 minus 4k1 plus 5k2 is equals to the coefficient of sine 2t there, which is 1. You only compare the coefficients, isn't it? Move to the next one, cos. The coefficient of cos here, remember the coefficient cos on the other side is 0. Isn't it? So it means what is this side you compare to 0. Is that okay? So the first coefficient of cos here is negative 4, negative 4k1. The next coefficient of cos, positive 2, positive 4k2. Then the next one, positive 5k1, isn't it? Is equals to what?
0.
The coefficient of cos 2t this side is 0, isn't it? Are we together? So simplify that just like this. This one means k2 taking the other side, k2 is equals to 4. If you take k1, 4k1 minus, it is better to use this second one, isn't it? It is better to use the second one. Negative 4k1 plus 5k1, you remain with k1. So it is 4k2 plus k1, isn't it? So that means k1 is equals to negative 4k. You use any method you are comfortable with, isn't it? Then if you use in the first equation, we have k2 minus 4k1. k2 minus 4k1 is equals to 1. k2 minus 4k1, but I'll put the value of k1 from this second equation, isn't it? The value of k1 is negative 4k, k2. So what do you get? k2 minus and minus is positive 16k2 is equals to 1, isn't it? So k2 plus k2, k2 plus 16k2, 17k2 is equals to 1, isn't it? So what does that imply? K2 is 1 over, what is k1? where there is K2, you put 1 over 17. You get K1 is negative 4 over, it is negative 4 times K2, negative 4 times 1 over 17, isn't it? So we found K1 and K2. So what is our complementary, what is our particular integral V? V, the particular integral is what? V was K1 cos 2t, isn't it? K1 you found to be negative 4 over 17. Negative 4 over 17 cos 2t plus K2 sin 2t. K2 you found to be 1 over, so plus 1 over 17 sin 2t. So we found U, we found V. So it means we found the solution x, which is the complementary function plus the particular integral. So x, which was u plus v, we found is what? What have we found to be the complementary function? A cos 2t plus b sin 2t into exponential negative t, isn't it? Then it is plus v. V you found to be positive 1 over 17 sin 2t and negative 4 over 17 cos 2t. You can arrange it the way you like, isn't it? Are we together? We now, after getting x to be this, we need to get the value of a and b using the boundary conditions, isn't it? So you get the value of a and b using boundary condition, we must differentiate x with respect to t to get dx over dt too, so that we have two simultaneous equations, isn't it? So the first equation is for x, the next equation we are looking for is dx over dt, meaning we differentiate x with respect to t, isn't it? So if you look at this is product rule, isn't it? This is product rule. So if the whole of this bracket you learn to be u, the other one is v, isn't it? So you can take exponential negative t step and you differentiate what is inside the bracket, isn't it? When you differentiate what is in the bracket, you get, if you differentiate cos 2t, you get negative 2, then our a sin 2t, isn't it? If you differentiate this, you get plus 2b cos 2t, then we took exponential negative t step, isn't it? Then it is now plus, we now take this bracket step and we differentiate exponential negative t. Are you seeing that? So if we take what is inside a cos 2t plus b sin 2t step, we now differentiate exponential negative t. We change it, we get negative exponential negative t. Differentiating exponential negative t remains the way it is. If you differentiate negative t, you get negative 1, changing this side. So you use product rule, isn't it? Product rule, you take this step, you differentiate this. Then plus, you now take this step, you differentiate this, and that is what we've done. Are we together? You let what is inside the bracket to be one thing altogether. Then, plus, differentiate sin 2t, you get 2 cos 2t, isn't it? So 2 times 1 over 17, 2 over 17 cos 2t. Differentiate cos 2t, you get negative 2 sin 2t, isn't it? So negative and negative changes to positive. 2 times 4, you get 8 over 17 sin 2t. You found everything. After getting x and dx over dt, meaning we use now the boundary conditions to get the value of a and b. Are we together? Can you now use the boundary conditions to get the value of a and b? Start with the first equation, x. When x is what? Where there is x, you put 3, where there is t, you put 0. So where there is x is 3, t is 0. So cos 0, 1. 1 times a, so you get a. Sine 0 is 0, the whole of this is 0, meaning inside this bracket will remain with only a, isn't it? Exponential negative 0, that's just exponential 0 is 1. Exponential anything, exponential 0 is 1. Anything raised to 0 is 1, isn't it? So it means the whole of this time we are remaining with a. Then here, t is 0, sine 0, the whole of this goes to 0, isn't it? Cos 0 is 1. So you remain with the negative 4 over 17. So what is the value of a? Give me the value of a. A, 4 over 17 coming this side is 3 plus 4 over 17, isn't it? So what is 3 plus 4 over 17? 55 over 17. Huh? Some of these things you just do. You don't need to waste time doing such kind of things. Then you move to the next one. dx over dt. You'll be told is what? 0. Where there is dx over dt, you put 0 to be equals to what? T is always 0 for both of them, isn't it? So sine 0, it means the whole of this goes to 0, isn't it? Cos 0 is 1, you remain with the 2b, isn't it? Exponential 0 is 1, meaning the whole of this term you remain with the 2. You move here. Exponential 0 is just 1, meaning we are dealing with what is inside the bracket, isn't it? Cos 0 is 1. 1 times a, you remain with sine 0 is 0, so you only remain with a here. So it is minus a. Negative is outside, isn't it? This minus, then we move here. Cos 0 is 1. You remain with positive 2 over 17. Sine 0 is 0, so here everything goes to 0, isn't it? So what is a? What do you get here? A you've already found. What was a? Where there is a, you put the value of a, which is 55 over 17. So give me the value of b, use calculator. Negative 55 over 17 coming this side, it becomes positive 55 over 17. Positive 2 over 17 comes, negative 2 over 17 is equals to 2b. Isn't it? What do you have? You get b is 53 over 34, isn't it? If you simplify. Here is 53 over 17, you divide both sides of the equation by 2. So you found the value of a and b. Having found the value of a and b, it therefore implies we can now get this, we can now write the solution of x. So the solution of x, where there is a, you put the value of a, isn't it? A you found to be 55 over 17. So it is 55 over 17 cos 2t, then plus b. b is 53 over 34. So it is plus 53 over 34 sine 2t. Then everything is times exponential negative t. Then it is plus 1 over 17 sine 2t, isn't it? Then minus 4 over 17 cos 2t. And you've actually found the solution of that given differential equation using the method of undetermined coefficients. That is how to handle that problem.